Alright, this is the study guide for Unit 5. Dolly, sorry, that was my dog, with her toy. I'm going to go ahead and record this and post it today. Dolly, no ma'am. No, right now. Alright, so Unit 5, we're taking a test over functions. Each one of these questions, I pulled the easiest question out of each lesson and made a version of it for this test. Some of them I did keep the same as in the lessons. Alright, so number 1 is fill in the table for this input-output rule. So remember, you're taking your input, you're using this rule. This is your rule. Dolly. Hey, no. You're taking your input number, and you're using that rule to get your output. So you're completing divide by 2 and add 3 to each one of these numbers. So we have 0 first. You're doing 0 divided by 2, which equals 0. And then you're adding 3. 0 plus 3 is 3. So your output is 3. Then you're doing it negative 12. So negative 12 divided by 2. That equals negative 6. You add 3. Negative 6 plus 3 equals negative 3. Then we have 4. 4 divided by 2, which is 2. And then add 3. Which is 5. Then you have 56 divided by 2, which is 28 plus 3, which equals 31. Sorry, I forgot to write that output. And that's all it is to it. So you're taking this rule, you complete it on these numbers to get these numbers. Alright, number 2. Complete the function table. This is the same concept, except it gives us an equation instead of an input-output rule. So it gives you your x values. Your x values are your inputs. It's the number you plug in. You've got to find your y value. You've got to find your y values. That's why this equation is y equals this, because that's what we're solving for. So you're taking 3 times x plus 7. These are your x values that you're going to do that on. So we'll start with x value of 2. So you have 3 times 2 plus 7. 3 times 2 is 6 plus 7, that's 13. So your y value is 13. Okay, then you do it with negative 7. So we have 3 times negative 7 plus 7. Dolly, stop. 3 times negative 7, which is negative 21, plus 7, that's a negative 14. Okay, then we have 9. 3 times 9 plus 7. 3 times 9 is 27. You add 7 to that, you get 34. Dolly. Sorry, she is on one tonight. Then we have 3 times 13 plus 7. 3 times 13 is 39. You add 7 to it, you get 46. And that's all. So all you're doing is plugging your x values into your equation, solving for y. Alright, let's look at the next one. Number 3. Use the diagram to answer questions. So here's our diagram. It's an input-output rule. This is your input. This is your output. This is your rule or your equation. I'll make that note. This is your rule or equation. Alright. Part A says write an equation for the function. So your equation is always your output, which is your y, equals your rule or equation. So it's just y equals 2x plus 3. So all you're doing is plugging in the equation behind the y equals. That's it. Part B, identify the independent and dependent variables. So remember, your input is your independent variable. Your output is your dependent variable. When you look at this diagram, the first thing you have, that's your input. The last is your output. So that tells you which one of these is which. So X, since it's your input, it's your independent. So X is independent. I'm going to abbreviate. Y is your output, so it is your dependent. And that's all you have to do on that question. So your input is always your independent. Your output is always your dependent. To write your equation, you just put your output variable, which is y, equals your equation that's inside of your box. All right, let's go to the next question. Number 4. This is what we're solving for a piece of a function equation. So we're solving for a piece of a function equation. This is supposed to say 60. I'm going to fix that. It cut off. I don't know why. I don't even know why it printed like that. But anyway, it cut off. That's supposed to say 60. A car is traveling on a highway and going either 60 miles per hour or 50 miles per hour until it reaches its destination 600 miles away. So we're driving 600 miles and we're switching back and forth between driving 60 or 50. X represents the time going 60 miles per hour. So X goes with 60. And Y represents the time going 50 miles per hour. So Y goes with 50. Here's an equation for the relationship. 60X plus 50Y equals 600. If the car spends 5 hours going 60 miles per hour, how long does it spend going 50? Show your work. So 5 hours going 60 miles per hour. We need to know how long it spends going 50. So we're going to be plugging in and then solving the equation for the variable we don't know. Dolly. So 5 is going to go with 60 because we spent that much time driving 60 miles per hour. Since that time goes with 60, it's going to plug in for X because X represents the time going 60 miles per hour. So since we went 5 hours going 60, X is going to be replaced by the 5 hours. So we're going to have 60 times 5 plus 50Y equals 600. Okay. Y represents the time we're going 50 miles per hour. That's why Y is the variable we're going to end up solving for. Okay, because we want to know how long we spent driving 50. So we're going to solve this equation. Remember, you always want to get rid of any parentheses first, so we're going to do that first. This is our distributive property. We're going to multiply the 60 times the 5. So 60 times 5, that's 300 plus 50Y equals 600. Okay, now we have a two-step equation. Okay, so we want to get 50Y completely by itself. So we have to get rid of the number that's on the same side as 50Y. That number is 300. So we're going to cancel out 300. Since there's no sign in front of the 300, you're going to subtract to cancel it out. That way it zeroes out. And what you do to one side, you got to do to both sides of your equation. So the 300s on the left side, they're going to cancel out. Okay, that's what we wanted. Then you're going to get 50Y equals 600 minus 300, that is 300. Okay, now we want to get Y completely by itself. 50Y is multiplication, so you got to do division to undo it. So this is the last step where you divide by the number in front of your variable. 50 is in front of our variable, so that's what we're dividing both sides by. Okay, on the left side, the 50s cancel out, leaving us with Y equals, and then 300 divided by 50 gives us 6. So it took 6 hours, or 6 hours going 50. Dolly. So again, you're just plugging in for the one it goes with, and then you're solving for the other variable. Let's look at the next question. Number 5. There are 2 tanks of water. The amount of water in gallons A in tank A is given by the function. By the function A equals 300 plus 16, where T is in minutes. The amount of water in gallons B in tank B starts at 400 gallons and is decreasing at 8 gallons per minute. Alright, part A says which tank started with more water. Alright, we read that tank B starts with 400. So tank B is 400. Tank A, it doesn't straight out tell us, it gives us an equation. So we're going to break down that equation. A equals 300 plus 16. Alright, this equation is still written in y equals mx plus b form. Okay, so remember, y equals mx plus b. M represents your slope, which is your rate of change. B, remember, is your y-intercept, which is your starting point. Okay? The only thing different about that equation that we have in this format right here is that it's got the m and mx and the y-intercept switch. So it's written as, I'll write that up here, y equals b plus mx. So it's got it switched around, okay, but it's still that same equation. So that first number, that's your start because that's your y-intercept. The 6 is your rate of change. Okay, so that means tank A started with 300 gallons. So since tank B had 400 to start, tank B is the tank with more water. Alright, part B. Write an equation representing the relationship between B and T. So we're going to format this the same way this equation is. Okay? Our uppercase letter, our water in gallons in our tank, that is our dependent. So that's going to be our starting variable. So we're going to have B equals, and we're going to put our y-intercept, our starting point first, just like they did. So our starting point is how many gallons we started with. Tank B started with 400 gallons. So we have B equals 400. Then we have to find our rate of change. Our rate of change is decreasing at 8 gallons per minute. Since it's decreasing, we're going to subtract instead of add. So it's going to be minus 8t. This is our equation. B equals 400 minus 8t. Alright, part C. Which tank is filling and one is draining? So when we did this problem in the lesson itself, we talked about the slopes. So when we're adding our rate of change in the equation, that's a positive slope. That meant the tank was filling up. When we are subtracting, or if it's negative, that's a negative slope. So that means it's draining. So negative slope's draining, positive slope is filling. So if we look at tank A is A equals 300 plus 16. This plus sign here means that it has a positive slope. So that means it is filling. So tank A is filling because it has a positive slope. Okay, which means tank B is draining because if we look at this equation, the rate of change has that minus in front of it. That means it has a negative slope. Plus, in the statement up here, it tells us it's decreasing. If it's decreasing, it's got a negative slope. So tank B is draining because it has a negative slope. So pay attention to your slopes when you're identifying which one is draining and which one of the tanks is filling. Alright, next question. Number 6. I pulled this one straight from lesson 7. The graph shows the temperatures between noon and midnight in city A on a certain day. So the graph shows city A. The table shows the temperature T in degrees Fahrenheit for 8 hours afternoon in city B. The table shows the temperatures for city B. Whoa. What did I do? Hold on. Did I delete that picture? Yeah, give me just a second. I'm going to pause the video and fix it. I have zero idea what happened there, but now it's fixed. The table shows city B. Which city was warmer at 4 p.m.? Alright, so we're going to look at city A, and we're going to go to 4 p.m., which is here. We're going to go up, and we're going to see the temperature. So at 4 p.m., that temperature looks like it's going to be at 57 degrees. Okay? So, when we look at the table, we're looking at hours. Okay, that top row is your time. Bottom row is your temp. Okay, so top row, we go to 4 o'clock, which is here, 62. City B had the warmer temperature. Oh, that's my marker messing up. Because it was 62, and City A we estimated to be 57. So City B. Alright, part B. Which city had a bigger change in temperature between 1 and 5 p.m.? Alright, so we're going to do a little bit of math here. So first we're going to find on city A, we're going to find the temp at 1 and the temp at 5, and then we're going to find the difference. So if we look at 1 o'clock, we're halfway between, this should be 50 and 51. So you got to make an estimate. I'm going to make that estimate. We're close to halfway. We're going to say at 1 p.m. it was 50.5 degrees Fahrenheit. Okay, again, if you said 50.4, 50.6, 50.7, somewhere close to that range, as long as you're not staying straight 51 or 50, that's still a good estimate. And then 5 o'clock, we look at 5 o'clock. We're just a little bit above 58. So we're going to go with 58.1 because it's literally right above it. If you rounded to just 58, I'd take that. If you said 58.3, something close to that, I would still take that estimate. Okay, so if you did the work and come up with something just a little bit different, don't panic as long as that your number makes sense. Now, if you put like 60 on this, obviously I'm going to be like, no. But somewhere close to that 58, I'm good. So we're going to find the difference between these two. So we're doing 58.1 minus 50.5, which equals 7.6. So that's got a difference of 7.6. Now we've got to test the same thing for city B. So if we look at city B at 1 o'clock, it was 82. And at 5 o'clock, it was 58. So you're going to do 82 minus 58, which is 24. So looking at that, considering this is 7.6, this one's 24, city B had the bigger change in temperature because it was way higher than 7.6. So city B. All right, one more question about these. Compare the outputs of the functions when the input is 3. So when you look at the graph, if you're looking at an input of 3, you're looking at your x-axis because your x is your inputs. So we're going to go over to 3, and we're going to find the output by finding the temperature it was at 3. So we're real close to 55. Okay? I'm going to say 54.7. If you say 54.5, 54.8, 54.3, somewhere close to that range, that is totally fine. Okay? Does not have to be the exact same thing as long as it's in that range and it makes sense. Okay? So I'm going to say 54.7 just because it's a little more than halfway. City B. When you look at the table, the top row is your input, so you go over to 3. You look at the temperature. It was 75 at 3 for city B. When we compare, we are finding the difference, so we're going to subtract. So I'm going to do 75 minus 54.7. I'm going to find the difference. That is 20.3. So the outputs between city B and city A when the input is 3 has a 20.3 difference. Again, I pulled that one straight from the lesson. I think my estimates were a little bit different in the actual lesson. But again, like I said, when we have these estimating problems where you got to estimate temperatures on a graph, as long as you're in a range that makes sense, you're still going to get the question right. Okay? Obviously, if it was 50.5 was a reasonable estimate and you put 54, obviously that's not going to be right. But if you put an answer that makes sense, it is going to be counted right. All right, let's look at the next problem. Number 7, sketch a piecewise function on the following graph. So a piecewise function, remember, is straight lines that follow the increase and decrease patterns of the graph. Okay, so we did this exact question in lesson 10. Okay, exact same graph and everything. So you're just making straight lines that follow the increase and decrease patterns of the graph. These lines are going to connect. Okay, they're straight lines because it's still a linear function, but the slopes change because of the increase and decrease is happening. So it's broken into pieces. That's why it's a piecewise function. So it's still linear, but we're changed direction, so it's going to be broken into pieces that are connected. Okay, remember when you sketch these, your line does not have to touch every single point. It's just got to be close to them. So see, mine misses a couple points here. Okay, I stop when it changes directions. I follow that short decrease right here. Okay. Then we've got a large increase. So I'm going to draw a straight line that hits most of those points. And then I'm going to draw a straight line that follows that decrease. That's all you have to do on that problem. Follow the pattern of the graph. Make sure that your lines are straight. Alright, let's look at number 8. A candle is burning. It starts out 10 inches long. After 1 hour, it is 8 inches. After 2 hours, it's 6 inches. After 3 hours, it's 4 inches. So before I even read the other part of the question, I'll make note that it goes from 10 to 8 to 6 to 4 every hour. So that's a change of 2, change of 2, change of 2. So there is a constant rate of 2. Okay, I wanted to make that note before I write the actual answer. Alright, it asks us, is height of the candle a function of time? Okay, so does the height of the candle, because the first characteristic listed is your Y, is your dependent, depend on time? The answer is yes, because the candle's on fire, it's burning. So the height of the candle depends on how long it's burning. So yes, and then it asks us if yes, is it a linear function? Explain. A linear function has to have a constant rate of change. Okay, that's why I looked at how it was changing before I even finished looking at the problem. Okay, because we notice it changes by 2 every single hour. So yes, it's a linear function. So, and yes, it is linear because there is a constant rate of change. Alright, next question. This is the last question on your study guide. We're looking at a piecewise function graph, answering questions about it. Lynn uses an app to to graph the charge of her phone. Alright, so here's her percentage charge on this side. Dolly, stop. Here's her percentage change. Here's her hours after noon. Okay, her phone starts off at 100. Okay, and then it starts going down, and it stays constant, and then it starts going up because she charges it again. Okay. Number 1 says, when did she start using her phone? So when she starts using her phone, that's going to be when it starts decreasing from 100. Okay, because we all know when we pick up our phone off the charger, as soon as we start using it, the battery starts getting lower. So as soon as it starts decreasing, that's when she starts using her phone. So I'm going to draw this line down. We're going to see what time. That is 2 hours after noon. So that's going to be 2 p.m. Okay. When did she start charging her phone? That's going to be when it starts going back up. It doesn't start going back up till this point here. So we draw a line down. That's 8 p.m. Okay. Then it says, while she was using her phone, at what rate was Lynn's phone battery dying? Alright, so here's where she starts using her phone. She starts using it at 2 o'clock. Okay. It goes constant at 4. So this is how long she used her phone, because the battery didn't change after that. 2 to 4, that is 2 hours. So she used her phone for 2 hours. We got to see how the battery changed. It went from 100 to 40%. So you're going to take 100 minus 40. That equals 60. So she used 60% on her phone in 2 hours. To figure out how much she used per hour, we're going to take 60 divided by 2. 60 divided by 2, that is 30% per hour. Okay. Alright, the bonus question answer was Dolly. My dog's name is Dolly. If you got that question right, you get a extra point in your study guide. If you have any questions on any of these problems, please let me know. And please use this video to study.